Welcome back, guys. Today I'll be proving an identity where I will show that the left hand side is exactly the same as the right hand side. Let's get started. Here I have the left hand side that I will be proving it's the same as the right hand side, which is 1 over tan x minus 1 over sine x. Now I'm going to change this where the tan x can be rewritten in a different form. Tan x in the denominator is the same as sine x over cos x. Once you have a fraction in the denominator, we can reciprocate it, which is the same as flipping it, so that becomes cos x over sine x. So 1 over tan x is the same thing as cos x over sine x, and this will assist me in getting the answer on the left hand side. So let's look at the left hand side now. So I will be looking at both the numerator and the denominator. In the denominator, I have 2 sine x cos x plus sine x. There's a sine x that's common that I can factor out. So I'll be doing that in the denominator. So factoring out the sine x, meaning carrying it outwards, and what is left, I'm going to create a bracket. I remove this sine x and this sine x, so it means I'm left with 2 cos x plus, since I've removed the sine x, it'll be plus 1. In the numerator, I'm going to leave the cos square x minus cos x, and I'll be changing sine square x to 1 minus cos square x. So that is the same as 1 minus cos square x. So changing sine square x, I will have what you're seeing written here. Now the sign, I am going to distribute it in the numerator. So it's going to change the sign of all of this that I have here. So rewriting the numerator, I will have cos square x minus cos x. Then distributing the sign, I have minus 1, negative times negative, so that's positive cos square x. And having this, I will rewrite the denominator as how I had it before. So nothing will be done to the denominator as yet. So let me go ahead, cos x, open bracket, 2 cos x plus 1. Now, in the numerator, I can add cos square x plus cos square x, and that will give me 2 cos square x. And then rewrite the other part, it's minus cos x minus 1. Now, in the numerator, this is a quadratic, but I will be rewriting it in a different form so you can actually see the quadratic. So I'll be looking at the numerator next. So here I have my numerator, 2 cos square x minus cos x plus 1. I will be letting cos x be a variable, and I will choose y. You could have chosen any other letter except the variable x. So I'm using y. So it means replacing this, I will have 2y squared, because I replace the cos x. And I replace the next cos x, so that would be minus y minus 1. Now factorizing this quadratic AC method, so we multiply 2 times negative 1, that's negative 2. So we need two numbers that multiply to give me negative 2 and add to give me the center negative 1. Those numbers are minus 2 and 1. So I replace the center with those two numbers. So I will have minus 2y plus y, which is the same as 1y, minus 1. Now grouping, so I go ahead and group. In the first bracket, I factor out what is common. I can factor out 2y. So what is left? If I factor out the 2 and the y, I'm left with y minus. Factor out all of that, so I put 1 as a placeholder. Factoring out just 1 is common, so I'm left with just y minus 1 in the next bracket. So here I have 2y plus 1, group them together, and y minus 1. Now remember y is cos x. So I have to resubstitute cos x. So this is the same as 2 cos x plus 1 times cos x minus 1. So I'll be replacing the quadratic in the numerator with what I have here. So let's do this. So the numerator, I will be replacing it with what I had just factorized and got. So here I am going to replace the numerator. So I have 2 cos x plus 1 multiplied by cos x minus 1. Now I'll rewrite the denominator. So I have sin x times 2 cos x plus 1. And I'm hoping you're seeing that I can do a cancellation because I have 2 cos x plus 1 in the numerator and the denominator. So there will be a cancellation right here. These can be cancelled. So what is left? I have cos x minus 1 over sin x. Now I can split this. This can be cos x over sin x minus 1 over sin x. So minus 1 over sin x. And I'm hoping you're seeing what I did with the 1 over tan x. We're going to work in the reverse. But before I even continue, if you're wondering, how did I split it? If I have 1 minus x over 3, it's the same as 1 over 3 minus x over 3. Both numerators sharing the denominator, so it's okay for us to split it like this. So looking back on the trig function that we have here, I have cos x minus 1 over sin x being split to become cos x over sin x. But I'm working in the reverse. Remember I did the 1 over tan x is the same as 1 over sin x over cos x. Working in the reverse, cos x over sin x is the same thing as 1 over sin x over cos x. Remember I've done it above. Now this is the same as tan x. So I can rewrite this even further to become, 1 over tan x, because I'm just working from the cos x over sin x, and it's the same as 1 over sin x over cos x. So I can even rewrite the sin x over cos x as tan x. So therefore proven, here we're seeing that the left is the same as the right. And that's it. Thanks for watching, guys. Don't forget to like and subscribe to my channel. And if you have more questions, you can leave a comment below. Have a great day.